Okay guys, today we're going to talk about multiplying polynomials. So last time we talked about adding and subtracting. Now it's time to move on to the next operation, which is multiplying. So we're going to start by just jumping into talking about the steps for multiplying polynomials, and then we're going to do a bunch of examples together. So the first step to do is to distribute. You've probably heard this word before in your math classes in the past. We see distributing a lot in math. One place you probably saw, well, the first time you probably saw distributing, it was when you were just adding numbers together, and you would see something like this, right? If you have 3 times 2 plus 5, you could distribute the 3 inside and make it 3 times 2 plus 3 times 5. Okay, we can do the same thing with polynomials. So let's just take a couple looks at what distributing would look like. So say I have a 3 on the outside of a parenthesis, and then I have a polynomial on the inside. So x minus 1 is a polynomial, and I'm multiplying it by 3. So my first step is to distribute. So I take this 3, and I multiply it to everything inside the parentheses. So one way to think about this is, in this first line, what I have written, we are doing 3 times everything in the parentheses, x minus 1. And I'm just going to rewrite it as 3 times each piece of the parentheses. Right, so now I have 3 times x minus 3 times 1. And then I can just multiply those to be 3x minus 3. Okay, so that's kind of a simple version of distributing. We are going to see more complex ones, like x plus 1 times 2 plus x. Maybe we want to multiply those two polynomials together. And the first thing I would do would be to distribute. So I would do 2, or x times 2, which would be, x times 2, plus x times x. And then I have to multiply this 1 by everything in the parentheses. That would be plus 1 times 2, plus, and my final distributing is the 1 times the x. So plus 1 times x. Okay, so I'd end up with 2x plus x squared plus 2 plus x after I distribute. Okay, the important thing when you're distributing, like we did right here when you have two polynomials that you're multiplying together, is that you have to make sure that every piece of your first set of parentheses is distributed to every piece of your second set of parentheses. So this x was distributed to the 2 and to the x, and this 1 was distributed to the 2 and to the x. Okay, my next step for multiplying polynomials is to combine like terms. Okay, this is going to look very similar to what we did when we were adding and subtracting polynomials. So let's just take a look at the example we started last time. In the last step, we had 2x plus x squared plus 2 plus x, right? And I see a set of like terms, 2x and x. Remember, a like term means that they have the same variable and the same exponent on the variable. So I'm going to add the 2x and the x to get 3x. So I have 3x plus x squared plus 2. So now I've combined all the like terms. Now I am ready for my very last step, which is to put your answer in standard form. Now remember, standard form just means that I'm starting with the variable with the biggest exponent and then going down. So for example, in this case, if I'm looking at the 3x plus x squared plus 2, the variable that has the biggest exponent is the x squared, so that's going to be the first piece. And then the next one would be 3x, because that's the next biggest variable, and then 2x. So this would be our final answer to that multiplication problem. Okay, so let's go through and do some examples of this, okay? I'm going to scroll down. Hopefully you have these notes written down somewhere. So let's go ahead and look at some examples. Okay, so let's just start with A. Remember, my first step is to distribute. So I'm going to take this negative xy and I'm going to distribute it in to each piece of the polynomial inside the parentheses. So I'm going to get negative xy times 7x squared y minus, and that minus comes because I have a negative xy right here, so minus xy times 3xy. Then I have a minus xy times a negative 11. Okay, so let's just go through now and just start simplifying each of my terms. So this first term, I'm going to use my exponent rules to combine these. I have a negative 7. If I combine the x and the x squared, I get an x cubed. And if I combine the y and the y squared, and the y, I get a y squared. Same thing with the next term. I have a 3, I have an x times an x, which is an x squared, and a y times a y, which is a y squared. This next one, I have negative xy times negative 11. Remember when I multiply two negatives together, it turns into a positive. So I'm going to be adding 11 times x times y. Okay. And I've already written this in standard form. Well, first of all, we don't have any like terms because if you look at the exponents between the variables, they're all different. One thing to notice is that we do have y squared and y squared, which are the same exponent, right? The same base and the same exponent. But since the y squareds are attached to the x's and the 3 and the 7, they are not considered like terms. So we cannot combine those. The next thing I want to do is make sure it's written in standard form. In this case, it is because I'm starting with my biggest exponent, which is 3, and then I'm going progressively down. Also note that in each of my individual terms, I wrote the x's before the y's because x comes before y in the alphabet. That's just one of the parts of being in standard form. Okay, let's look at b. So b, we're going to distribute this m to everything in the second set of parentheses. So I'm going to get m times m plus m times negative 8. Then I'm going to distribute this 3 in to get 3 times m plus 3 times negative 8. So I'm going to have m squared minus 8m plus 3m minus 24. Okay. So we'll combine the negative 8m and the 3m. So negative 8 plus 3 would be negative 5. So my final answer is m squared minus 5m minus 24. Okay. So eventually you'll probably get to the point where you will be able to skip this first step that I wrote down and jump right to this second line, the m squared minus 8m plus 3m minus 24. And whenever you feel comfortable doing that, that's totally fine. Just make sure that you're showing some work before you get to your final answer. Okay, let's take a look at C. This one looks just a little bit different because I have coefficients in front of my x's, or numbers in front of the variables. So I'm going to distribute the 3x into everything over here. If I do 3x times 5x, I'm going to get 15x squared. 3x times negative 2 is going to be a negative 6x. Then I distribute the 1 in. So 1 times 5x is going to be 5x. And then 1 times negative 2 is going to be a negative 2. Okay. So now I've distributed everything. Now I've got to combine like terms. So I have 15x squared minus just 1x, because negative 6x plus 5x would just be negative 1x, and then minus 2. So that's going to be my final answer. Note again that this one is already in standard form because I'm starting with the biggest exponents and then going down. Okay. I'm going to let you guys work through most of these other examples by yourself. I'm going to jump to the end and work through some trickier ones with you guys. So let's look at K. So K looks a little bit different than the ones we were just barely doing because the first polynomial has 2 terms, it's a binomial. The second polynomial has 3 terms, it's a trinomial. So we're going to work through this example and you're going to see that it actually is pretty much the exact same as what we were just barely doing. The idea is that I have to take everything from the first polynomial, so from the 2x minus 3, and distribute it with everything in the second one. Okay, so I would get 2x times 5x squared, which would be 10x cubed, and then 2x times the negative 6x, which would be negative 12x squared, and then 2x plus 7, which would be 14x. Then I have to distribute this negative 3 in as well. So negative 3 times negative 5x is negative 15x squared. Negative 3 times a negative 6x is 18x. And negative 3 times a 7 is going to be negative 21. Okay, so the key here is that I just took everything from the first set of the first polynomial and just distributed it to everything in the second set. Then I get this huge long slew of numbers. I'm going to start combining like terms. First of all, I see that I have some x squareds that I can combine. So if I combine negative 12x squared and negative 15x squared, I get negative 27x squared. I'm going to bring down this 10x cubed. I don't have any other x cubed, so I can't combine it with anything. The next thing I notice is that I have some x's I can combine. I have 14x and 18x, and those combine to give me a 32x. And then the last thing I have is just this minus 21 that I'm just going to drop straight down. Okay. Note that this again is in standard form because I'm starting with the biggest exponent of 3 and then decreasing. So with these ones that have bigger polynomials that you're multiplying, you're going to follow the same process of distributing. You just have more to distribute, so it's just going to take a little bit longer. And be very, very careful with how you multiply to make sure that you don't make any silly mistakes in your multiplication.